Hello everyone. Welcome back to my channel. Today, I will be presenting on the topic, from hardware to software, covering brief definitions and distinctions between processor, CPU, CPU core, CPU thread, kernel thread, and user thread. Let's get started. Don't forget to subscribe so you never miss a new video. Most of us are familiar with the basic components of a computer, which include PSU, power supply unit, mainboard, GPU, graphics processing unit, storage, commonly HDD and SSD, RAM, random access memory, and CPU, central processing unit. No, technically it is not called a CPU, it should be referred to as a processor. Check out Intel's website. This is an Intel Core i9 processor, not an Intel Core i9 CPU. The website also mentions CPU and core. Or you can check out AMD's website. A processor includes GPU, I/O controller, memory controller, cache, commonly L3, and CPU, central processing unit. A processor is a device or electronic circuit capable of performing calculations and processing data. It includes various types such as CPU, GPU, DSP, digital signal processors, and others. A processor can integrate multiple subprocessors, such as a CPU for general processing, a GPU for graphics processing, and a DSP for digital signal processing. Next, we'll look at the CPU and CPU core. In this section, to make things clearer, I will refer to the core in CPU as CPU core. A CPU can have one or more CPU cores. The L1 cache is typically divided into two parts, one for storing instructions, L1I, and one for storing data, L1D. L2 cache may be located inside or outside the CPU, but it is always closer to the CPU than the main memory. A CPU core consists of several components such as the arithmetic logic unit, ALU, control unit, CU, memory unit, MU, registers, clock, and various other elements. Here is an overview of the CPU and CPU core. Typically, a CPU core corresponds to one CPU thread. However, with simultaneous multithreading, SMT, technology, a single CPU core can support more than one CPU thread. Despite this, the performance of two threads on a single CPU core using SMT technology is only about 30% better than one CPU thread on a single CPU core. The operating system scheduler maps a kernel-visible software thread to a hardware thread, CPU thread. I will create another video to discuss the scheduler, context switching, and related concepts. The thread model maps threads from kernel space to user space. In this video, I have provided a brief overview of some easily confused concepts. I hope that after watching, you will have a clearer understanding of them. If there are any mistakes, please don't hesitate to leave a comment. And don't forget to hit the subscribe button and the notification bell to never miss a new video. Thank you.